So, you may look at the periodic table and see these numbers, but what do they mean? Essentially, that's the number of electrons and protons. That means there's 12 protons and 12 electrons. There's the same amount of electrons and protons for everything. So, like magnesium, the center, would have 12 protons. And then around would have 12 electrons. So now that you know that, now we can learn what valence electrons means. Okay. Valence electrons is like how many electrons are on the outside. So let me show. So lithium has like one valence electron. So one out of those 3 electrons I'm going to put on the outside. But we still need 2 more. So we put them on the inside. Only 2 electrons can be on the inside. Now that we know what valence electrons are, the ones that are on the outside, we can learn about this column. So there's these things called rings, like hydrogen would have 1 ring around it and 1 dot because it has 1 electron. Lithium has 2 rings and would look like that, with the 2 rings. Sodium would have 3 rings and, 11 electrons with 1 on the outside because you always need to have 1 on the outside for this column. This one would have 4 rings, 5 rings, 6 rings, 7 rings. And then this column always has 2 valence electrons. So I'll do an example. Beryllium is in the second column. So that means you had 2 rings. And then it has 2 valence electrons. So 2 out of the 4 you need to add to the outside. And then you need another 2. So you add it on the inside. And that's kind of an example. So you actually won't be using this middle column pretty much at all. At least from what I know. So you can just cross that out. You may use zinc. Okay, I actually covered it up. But I'd be surprised if they do. So it doesn't actually matter. Anyway, so these have 3 valence electrons, 4, 5, 6, 7. And you've probably heard, but in order for an atom to be happy, they need 8 electrons. So essentially, like, all these atoms are, like, gonna, like, for example, beryllium has 2 outer electrons, so it needs to bond with a atom with 6 electrons to add up to 8. So you could have, like, beryllium, this one, and then have oxygen or something. And essentially, that would mean that, like, here, let me try it out. Beryllium, and then oxygen. Oh, this is the second row, so it has 2 rings, and it always has to have 2 on the inside. And then I've already done the 2 on the inside. So, okay, so every is up to 6. So I'll just add to the 1, 2, 3, 4, 5, 6. So anything under 4, you'll just subtract. So you'll take these away and bring it to oxygen and stuff, because then it would be 8. Then, like beryllium, atoms are always happy if they have 2 valence electrons or 8. So that's one thing to figure out. Like helium, it's happy with 2. Same with hydrogen and lithium and beryllium. Those are the only ones that are good with having 2. Essentially, just like when you're doing all this and it seems like it won't have enough to have 8 on the outside, then it's just 2, then you'll know. Another thing that will probably be on the test is this, where it's essentially like, well, what is this? Well, actually, one thing I want to explain first. So, charges. Let's, let me look here. Sodium. Okay. Wait, I forgot to see what the number was. 11. Okay. So its number is 11, right? Wait, how many valence electrons does it have? It has 1. Okay. It has 1 valence electron. And, oh, sorry. Okay. So, in order, it's like, what charge would this have if it was happy? In order to make this happy, first you'll, like, make a model. So, Na. Check what row Na is in, so it's in 3. So we make 3 rings. 1, 2, 3. And we know it has 1 valence electron because it's on the periodic table. Right here. And essentially, we add that 1 electron. And then we add the other 11. We have to make sure that there's 2 on the inside. And then however valence electrons are on the outside. In this case, it's supposed to be 1. And then 11 minus 3 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So it's like, what can this atom do to be happy? Well, since it only has 1 valence electron, it can just get rid of it. And it would be left with all these 8 outer electrons. So let's find sodium. Oh, sorry. So look here. We're gonna find, so it would be argon in the end. So like it would be turning into argon since it's, just like a cross. But that doesn't totally matter. Okay. Anyway, how do you find out the charge of this? Well, since you removed one electron, and we know that Na also has 11 protons and 11 electrons. Remember that the number that's on the periodic table is the amount of electrons and protons, so it means it has 11 electrons and 11 protons. When you take one of those electrons away that was on the ring and take it out, then that means there's 10 electrons and 11 protons. So it's like it'd be more positive than negative, since 11 is more than 10. So if there's more protons than electrons, then it's a positive charge, a positive one charge, because only one was removed. Okay, and how do you do it if it's gaining stuff? Here, I'll do an example. Okay, let's look at the periodic table, for example. 1, 2, 3, 4, 5, so 6. Let's do oxygen. Sorry. Okay. It would have 6 valence electrons. Now let's look at the table. Okay, its number is 8. It's crossed off, but it's 8. So it has 8 normal electrons, or just electrons. Let's see what row oxygen is in. It is in the second row. So, no, it doesn't matter. So that means there's 2 rings around oxygen, and there's 6 valence electrons. So what you're going to do is add 6 to the outside. 1, 2, 3. Yeah, okay, that's right. And then what you would do next is, you've already gotten the 8, so you just need 2 more left. So the 2 more go on the inside. So what would it easier for oxygen to do to get 8? It'd be easier for it to get to, since there's already 6. So it's it'd be way easier to get to instead of getting rid of 6. So, since there's also 8 protons, since it'd be getting 2 more electrons, 2 of them, that means that now there will be 10 electrons, so now there's more negative than positive, so it would be a negative 2 charge. Okay, now it's time for me to explain this top part and what it means. Okay, so you'll probably see something like this, where it will have the name of something, and you'll have to find the formula. So essentially, how you do that is you find calcium on your periodic table, then you find the letter, then you find oxygen, just see what it starts with and what chemical it sounds with. So that's oxygen. Also, it'll always be a metal and a non-metal at the end. And essentially, calcium has 2 valence electrons and oxygen has 6, so they just add up to 8. So you don't need to add any numbers. Let me show you a situation where you would need to do that. 1 sec. Okay. This is sodium, and it has 1 valence electron. And then let's find something. Fluorine. Oh wait, actually 1 sec. Let's do oxygen. Yeah, let's do oxygen. Okay. 06. Essentially, it's like, it would be something like, what's sodium oxide? Which means oxygen, by the way, but you always have to end it with ID. Anyway, so, oxygen has 6 valence electrons, but needs 8. There's only one of these. So, in order to get 8, you would need times 2 of that. So, it would be like sodium. 2 of them, if you had 2 sodium, it'd be like 2 valence electrons, adding up with like 1 oxygen, since it has 6. And stuff like that. And then normally you will also see this, and essentially you have to look at the periodic table and then list out the name, like sodium, and then you find this and put oxide. Honestly, I'm not sure if you'll understand all this. I'm trying. Sorry.